Hey everyone, Mr. Fransky here again. Today I'm going to talk about how to find the derivative at a point of a function on the TI Nspire. So students will be able to find the derivative at a point using their calculator. This is something that AP expects you to be able to do, and no time like the present to fit it in. So let's take a look. So derivative and tangent line are things we're going to talk about today. Figure out how to find those on a calculator. So finding the derivative at a point. This one I want to try one that we can do by hand pretty easily just to show that the calculator does all the work for you. So f of x is 3x cubed minus 2x squared plus 7. We want to find f prime of 2. So first we'll do it by hand. Well, f prime of x is going to be 9x squared minus 4x. That's it, right? So if we want f prime of 2, f prime of 2 is going to be 9 times 2 squared minus 4 times 2. Remember that what this is going to do, this is a cubic. So something like this maybe. So it's going to find us, let's say 2 is right here. It's going to find us the slope of the tangent line at x equals 2. So 2 squared is 4 times 9 is 36. I'm thinking my graph is not going to be accurate because it's going to give us a positive number. Minus 8 gives us 28. Okay, so that would be the slope of this function at x equals 2. And now let's see if the calculator gives us the same thing. I'm going to go over my calculator here. I'm going to go to my documents. And I'm going to scroll down. I'm going to go to Calculus BC, or AP Calculus, either one, whatever you made in your calculator. If you need help making that document, make sure you watch that video about setting up a calculus document. Very important for the test especially. So what I'm going to do now is I am going to go to Menu. So on a calculator window, just like this one, I'm going to go to Menu. I'm going to go to Calculus and do derivative at a point. If you have a CAS, you have just derivative as an option as well. I'm going to go derivative at a point. All the calculators have this somewhere on this list for calculus. So variable is x, that's just fine. The value I want to evaluate it at, I think we said was x equals 2. So I'm going to evaluate it at x equals 2. First derivative is fine. You could also do a later derivative, second, third, nth derivative. They'll take anything you want. Okay, so first derivative is good. So now notice we have this Leibniz notation, the derivative of what function evaluated at x equals 2? Well, I want that to evaluate it at 3x cubed. What is it? Minus 2x squared plus 7. Now when I hit enter, it's going to do all the work for me. It should give me 28. Let's see what happens. And there it is. That's all there is to it. So let's see how this can be applied. So f of x equals cosine cubed x. They want us to find the equation for the line tangent to f of x at x equals 2. So cosine cubed x, we could probably do the derivative of that, right? It would be chain rule, right? The 3 would come to the front, and then we multiply by negative sine x. But calculator would do it all for us. So we need a point and a slope for the tangent line. So we need a point and a slope. So the point, x is 2, and then cosine cubed of 2. Let's find out what that is. So our calculator window, cosine, I think I have to do cosine of 2, and then we'll cube it. So I'll find out what that is, and we'll cube it. Gives me negative 0.07206. Let's write that much. Negative 0.07206. Remember, we need 3 decimal places. So 0.072 would be enough to stop. I like to go a little further. Now we need the slope. Well, that's just f prime of 2. So we go back over, go to Menu, Calculus, derivative at a point. X is fine. I want to evaluate it at 2 again. First derivative is great. And I'm going to put in cosine of x. I'm going to put it in parentheses. Cosine of x. I never trust putting the cube in the middle. I like to do the whole function and then cubed. Hit enter. And we see that it gave us that chain rule. I'm going to do control enter. If you do control enter, it'll give you an approximation. Negative 0.4724. So now I just put pieces in place. So we have y be plus 0.07206 equal to negative 0.4724 times x minus 2. Oh, not x, 2. There we go. And that's how we find our derivative at a point using our calculator. Not too bad at all. Love you guys. That's why I'm here. Have a great day.